Someday I'm gonna catch up.
Speaking of catching up, guys, I think we're on the radio. We're on the
Oh
air.
boy.
We're on now.
Still on
Okay.
a radio budget.
I'll get plugged
Hello,
in.
Being
everybody, and
recorded on
happy
live stream.
couple days. Let's talk here. The six of us on screen. By golly, this is the Big Astronomical Unit's 250th episode of what we call the SBAU Astro Hour. My name's Ronnie Herron. Proud to say that myself and one other gentleman on the screen I'll introduce you to here in a minute were reelected. It was a hard-fought battle, even though we ran unopposed, and it was Friday night at our big in-house members-only science speakers meeting last Friday. This is a hell of a week for us. We got our big holiday party Thursday night out at the Hilton in Goleta, and we're all paid up, and about 40 of us are going to break bread and make merry. And then Saturday afternoon, next weekend, the 13th, we meet for our fourth online meeting, a planning meeting, followed by a night under the winter skies at the museum. Ooh, it's the star party. Welcome to the Astro Hour, and listen to my crummy voice. That's okay. I call it the Maud Frickert routine that happens to old people. It's an old character of Jonathan Winters. Let's get today. Oh no, let's first, before I introduce you, gentlemen, coming up this weekend, Geminids, meteors are us. A comet named Shumasa, an asteroid that thinks it's a comet, with the waning crescent moon out there. A small but fairly bright lenticular galaxy, NGC 3607, happens to be in the equatorial constellation Leo. We're going to talk about that. And an infrared view of how dwarf galaxies merge, evolve, trade gas, ignite waves of new stars, make love, even marry. All taken by JWST. Well, speaking of JWST, you ever heard of the Hubble tension? It's a rivalry and envy you wouldn't believe. The new leader of the Space Telescope pack. Actually, the Webb is out there, the Hubble's out there, but a new cosmic map just got the mystery deepening. And speaking of comets, that C/2025 R2, the Swan, just took a punch from NASA. And gentlemen, we're all going to be surprised by the new silly science cartoons that we haven't seen yet. Let's meet the man behind it all, going into our sixth year. Hello, good morning, Mr. President. Again, Jerry Wilson.
Good morning, everybody. Good morning to my sister Joyce and Riley and Calvin, my two grandkids. And sorry about the cartoons. I had them all ready and I just got carried away.
Well, it's all going to be ad lib and extemporaneous as we see them, because I haven't had a chance to write any lines down. Who was the lady that Jimmy Durante used to say good night to? You want to include her?
And good night, Mrs. Calabash, wherever
you are, yeah.
Okay, he's married to Pat Porgy, and she is a sweetheart. She is wonderful. She compliments me just like Tim, and I'll introduce you to him in a minute. Captain Outreach has been in the club for decades. Chuck McPartland, from the Ukraine flag, in charge of our events, and is out, I think, more than half the year at night. Pat McPartland, his wife, is merch manager, as well as newly reelected treasurer. God bless. Let's see who joined us in order. Tim Crawford, married to Karen. Hiya, Tim.
Heidi.
He will be one of our two speakers next December in House membership.
You are starting early.
That's right. We're going to get him drunk and write a script for him and put together a PowerPoint. Who else is on board? By golly, everybody's here. Bruce Murdock signed in. Bruce, how you doing? How's the Theater Organ Society? You guys still meeting once a month as well at the Arlington?
Yeah, we don't have, they do the Nutcracker in December, and they disassemble the stage and actually uncover the orchestra pit, and there's a real orchestra down there. So the organ console gets disconnected and rolled backstage.
Oh,
so it's not working right now.
And none of those huge pipes in that little Spanish village on both sides of the Arlington stage get used in that Nutcracker, do they?
No, they don't.
Some of that could sound so great. Hey, look who's with us. The editor of our newsletter, former Westmont College science professor Tom Whittemore. How are you, Tom?
Morning, fine, thank you.
Married to Maureen. Bruce is married to Bonnie, and it's time for the silly science cartoons. Before we go deep into space, let's take it on and be surprised. And you guys, I may just pass it around. And if I can't read it, maybe you can. Mr. President puts these on. We've got a store of these over the years, going on 6 years. Yeah, that's going to have to be enlarged.
They're not on the email that Jerry sent around, right?
No.
I don't see them.
That's all right. He's a busy man. What you want to go through this and tell us? This looks like Gay and Wilson.
Yeah, I think, yeah, it is right there. Gay and Wilson.
Oh, yeah. Okay.
Yeah.
You got
This
these out
is-
of your old Playboy magazines, did you?
I don't know about that. This is Lab H. It says that it's restricted, and these guys in lab coats have just opened the door and looked out on the universe.
Oh,
One of them said it looks as if Bodeker's project has gotten completely out of hand.
now I get it.
There was some. Okay, here's another one. Anybody want to try that one, Chuck? What are we looking at?
Well, you got a bunch of cows sitting there on laptops and looking at a monitor and running a blender. And the farmer is sitting there and says, I don't think the new electric fence is engendering the fear we intended.
I'm glad you could see it. How about Tom Whittemore taking this one?
Let's separate fact from fiction, people. I don't believe in astrology. We Geminis are smarter than that.
Geminids.
God.
And that's Garfield, right? The cat.
Yes.
Yeah.
Bruce, you want to try one? You want to read it? Bruce?
Pardon? Oh, I don't see any. I hate it when Google says things like, today is Marie Curie's birthday. Tell me a week before so I can get her something. Well, she's been dead for 100 years.
There's something with radium in it or on it. All right.
No, well,
Mr.
she
President.
discovered radium.
I know, but she died of it too. Did you know that?
Yes.
Oh, yeah, right. Well,
Radiation
the
poisoning.
other thing is that the women that put the glow in the dark stuff on the
Radium.
hands of a watch got, they would always wet the little tiny brush they used with their tongue,
Oh,
and
dear.
they dip it in the radium and then paint it on, and they ended up with cancers too.
Cancer.
Horrible cancers.
All right, I'm going to let the president do this one.
Says I barely passed my astronomy class. I identified Ursa Minor, the bare minimum.
Very good.
And here's your solar system at night. Okay, what are we looking at specifically that's different?
No sun.
No sun.
Oh, oh God.
Didn't stay. I looked everywhere but there. Okay, we're looking at what is that? The Death Star from Star Wars?
No.
I
In the
love old
50s and
science fiction.
40s and 30s, they had
Something's happened.
really weird art to go along with science fiction magazines, comic books, and books.
Mhm.
And this is a play on that. I love old science fiction. They have stories that begin with, it's the distant year 2003, and humans are exploring the deep corners of the universe. God bless you, old sci-fi. You had such high hopes for us.
You ever see the movie Metropolis?
Metropolis, yeah, from the 1927, I think it was.
Can you order that in YouTube or
Sure. Yep.
not even?
Everything you've ever seen, with the exception of Song of the South, you can order.
Yeah, with the
The,
exception of Song of the South. One of the
Santa
best.
Barbara Theater Orchestra Society put Metropolis on, with live theater accompaniment as one of
Did they
our.
really? Can you imagine what the themes they played on the original? That's because all those old silents were accompanied, weren't they, by organs?
The only
Yes, that was that replaced the orchestra. They used to have to hire a lot cheaper.
Is this a cartoon or are we starting off with the goodies, Mr. President?
I would make one last comment about the Song of the South. That was Uncle Remus stuff.
Yeah.
The only thing I remember about Uncle Remus is that my dad used to read to my sister and I, and every once in a while we'd give him one of those Walt Disney books with the stories, he could never make it through one of the stories without completely falling down laughing until he couldn't finish it.
Yeah.
It was just amazing.
I used to do that for my kids too, reading her the Uncle Remus stories. And
Yeah.
they're hard to do and keeping in character.
Yeah,
was in the-
exactly.
I was
Yeah.
in the I was in the sixth grade, bawling my eyes out in the front seat of the theater with Song of the South, and later they pulled it, and I couldn't figure out why
Yeah.
until just recently.
Yeah. Yeah. Me
Yeah, the
too.
blacks
Culture
looking
has
at
changed.
Uncle Remus going zippity doo dah, oh my, oh what a wonderful day. They didn't have wonderful
That was
days.
a good song.
Man.
So this is the orbit of an asteroid, Phaethon. And these are, do I have I guess it's only in the talking points, the legend down there. It color codes each orbit to tell you what it is. And let's see, Mercury is,
The third rock from
Mars.
the sun.
yeah, Mercury is here, Venus, Earth, Mars, and the orbit of this asteroid, which does not conform to the asteroid belt. There's a word for this category, but I forget what it is.
Or the ecliptic.
Yeah, or the ecliptic. And this is the closest asteroid that comes to the sun. This is
Wow.
less than, I think I put it in there, it was less than
Like 13 million.
0.14 AU. Yeah. And this is the source of the Geminid meteor shower.
Really?
Yes. And the Geminid meteor shower is a broad shower. It's underway now, but it peaks on the 13th and 14th, which is this coming weekend.
Mhm.
Oh,
And it gets quite a good show. And the moon will be close to new moon. It will be past the last quarter, so it should be dark enough so you can see something.
And that's UT for the peak. So it's actually on the 12th and 13th for us.
okay.
Really? So start party, we might get some meteorites.
Yeah. Yeah.
Mhm.
And the nice thing is Gemini rises early. So you don't have to wait till after midnight, although it still gets a little better then.
Yeah, it helps if you're after midnight.
But does this sucker steam any tails? Does it ever have any water in
No.
it?
No,
Okay.
it's burned out as far as being a comet.
Okay.
But it spalls off flakes of stuff because the heating is so extreme. So the Geminids are known for fireballs because they're tougher, they're rocky.
Huh. So all those radiants aren't past comets that are never coming again. They're regular comets that come and retrace the same path, I guess, huh? All the different
Well,
radiants.
no, some of them are comets that are gone. And that's kind of what this is, although it still has a rocky core left.
When you say gone, where do they go? Do they get swallowed up?
If they're primarily ice, they just go away.
Yeah, they're
Primarily
primarily
ice.
following this orbit too. They came off of the asteroid, so they don't follow it exactly. They have a
Well,
divergence in velocities.
well, Ron was talking about other comets.
Oh, other comets, okay.
Hmm. We get
Okay.
a shower about every week.
Well, you get sporadics all the time.
Yeah.
Hmm.
They're not in elliptical orbits then. They're in
Now, this
hyperbolic
is
orbits.
This is in honor of Chuck.
Yeah. Good luck finding anything with this chart.
Yes. Well, anyway, I've translated this one. On December 1st, up here near Gamma Leonis, this is the constellation of Leo, which there it is, the word Leo. So Gamma is here. The comet is going right down this way, and it passes between Delta and Theta. So if we look here on this map, this is Delta and Delta there and Theta there, and this is Gamma here. So it comes from right about Algeba, and it goes right straight down here through this part of Leo during the month of December. And what we're looking at is a comet. And the comet is 24P, so it's periodic Shumasa. I've
Show,
never seen it
show
before.
us.
Yeah.
Shumasa.
Yeah,
Germanic.
So anyway, going back to this one, this is of value because it really highlights this very rich Leo region of galaxies that are great objects. And the comet is going right down here. We are, what is the date today? 8. So we're about right here.
Mhm. Mhm.
And on the 12th, we're going to be passing this tight little cluster of galaxies. And you'll see the comet go through that area. And this is one of those pictures. This is NGC 3607. And it's a very interesting galaxy. It's a very
Flocculent.
bright, what's that?
Flocculent.
Yes. Bah.
Yeah.
This is
Middle of it looks like a
is
face.
Huh.
I don't see a reference to, oh, I see, here we are, image by Judy Schmidt,
Yeah.
Hubble Space Telescope. So
Oh, wow.
you won't see this in your scope, but you
I
will
was just
get a
gonna
good view
say,
of galaxy.
I'd have trouble carrying that into the star party.
Yeah.
We're looking at a comet without a tail.
And this is the
It's a
other one right
galaxy,
next to
Ron.
that.
It's a
Oh,
galaxy.
galaxy. I'm sorry, I missed the transfer. I didn't think it looked like one. That's the galaxy. Okay.
And this is the other of those two galaxies. And this is taken by the Sloan Digital Sky Survey and processed by an unknown grad student. So this is a elliptical galaxy, no structure to it that's visible.
Oh,
Wow.
There's nice galaxies in the background. This is a very rich region because you're looking away from the Milky Way. You're looking out of one of the poles of our galaxy or near it.
and near that, on the tail of Leo, there's that Leo triplet. What is
Right.
it, 95,
There's
90?
the other triplet here too, Tim.
Yeah.
Yeah,
You know, it contains 105.
Oh, yeah.
yeah, right
95,
up,
Right in
96.
there.
Yeah.
That's it. 105, 95, 96.
Yeah.
Yeah. And then 65, 66, and then there's another one there.
Hamburger. Chuck
Yeah.
calls it a hot dog.
Yeah.
38, 26, something like that.
So the comet again is going from right up here, right straight down.
Yeah.
So it's going to be a good part of the sky to look at.
Yeah.
If
Yeah.
you're a night owl.
Well, yes, it has to be at night.
I mean, late at night.
Yeah.
Right. Yeah.
Goodness, what is this? What science fiction movie scene are we looking at here?
This is
Wow.
let's
This is
see.
the extremely large telescope.
These are this is just to avoid confusion. This is the extremely large telescope. It is under construction right now. And but we're going to show data from the VLT, very large telescope. So that's not this telescope. But this is cool.
798 segments. Oh my God.
Yeah, you see them. They're real little hexagonals in there.
So video telescopes are getting as large as radio telescopes.
Yeah.
Yeah, they're
Ron,
sticking
have you
up
heard about the
Yeah.
Has Ron heard about the ELT?
The what?
Not the BLT,
Very
the
large.
ELT?
Very large.
Even larger telescope.
Oh,
This
yeah.
This is the ELT.
Yeah.
Well,
And there was going to be the
The BLT is
OWL,
the
the
big large
overwhelmingly
telescope.
large telescope.
Right, the
Yes.
owl.
That one was canceled,
Yeah.
unfortunately.
You know, the optical path in that illustration is confusing because I don't understand how the light that's reflected from the primary mirror gets down to the secondary mirror and goes through that mirror in the middle.
Yeah.
Yeah, just follow the paths.
Follow the path. It's
Comes
right
to a
there.
focus here, and then it spreads out again.
Right.
Well,
back
so
up
there's
there.
a hole in the middle of that
Goes over-
second mirror.
And you stack up all the books in the library to get up to here so you can see it.
Why do you suppose they don't line up optical telescopes in a row out on the desert like they do radio telescopes. It's just
They
wild.
do.
They
They
do.
do.
Do
Yeah.
they do opticals like that?
Yes,
Mhm.
I didn't know that. I've never seen them.
but not big ones.
Okay, they're not big, but they're in a row.
Yeah.
The equivalent aperture is very big and the resolution is very high,
Mhm.
but they're not as dramatic to look at the array, I guess, as
But you
Gary,
got
what's the altitude of this place?
gosh.
Something like
14,000.
18,000?
14.
They're all way up on some. I didn't note that, but they're all way up in the Andes.
Right.
Yeah, it's going to be
Could be
12 or
upwards of
14,000.
Yeah, it could be even 16,000 feet.
Wow.
I know that LCO is putting one up at 18,000 feet, and that's going to be the highest one.
Wow.
Wow.
where?
Nepal, or not Nepal.
In China?
Well,
Yeah,
Huh.
it's the part of Tibet.
Okay.
Oh,
the Andes
wow.
are that high, aren't they?
No,
The
they're
Andes
they're
are that high?
14, 16.
Okay.
Oh,
At
okay.
18,000 feet, you need supplemental oxygen, do you not?
Yeah.
Oh, God, yeah. Oh, yeah.
Oh.
So going back to summarize, this is the ELT.
Okay.
This is the VLT.
Oh,
And Ronnie, you see those little eggshell clamshell things?
Yep.
That's where they're doing the equivalent of a radio telescope. That's an array.
You're kidding. Those are smaller than the big suckers are optical then, right? The big square.
They're all optical,
Yeah.
and they can use the big ones and the little ones together.
Yep.
Yeah.
So
What
the
you
big
just-
ones provide sort of the amount of photons, and then the little ones provide you with the aperture size, so the resolution.
Yeah.
Yeah. And
Well,
you see
I
the
thought
little
all
ones,
the big
Ron, are
ones
on
were-
rails. You see the little ones are on rails. See that?
Chuck
Yeah.
just said the little ones were radio.
They're on
No,
rails.
Oh,
You
rail.
can move them like they
Oh.
do radio scopes.
There's more out here too.
Yeah.
yeah, there are more positions where they can put them, so they
Yeah.
can configure them however they want to get the data they want, the type of data.
Oh, are those
Oh.
the ponds you saw in the backyard of LCO when we were out there?
They're similar.
Yeah.
They look like the thing Keir Dalia went for the other astronauts when Al killed him. Remember, he came out with the arms. That's the only thing that's missing is the arms.
So if you were to take only two of these, say this one, and none of the rest were here, then the equivalent aperture that you see would be a single mirror with a diameter equal to this distance.
huh.
Oh,
It would not have the light gathering power of the big telescope, but it would have the resolution of the big telescope.
But they
Wow.
optically combine the outputs of the big telescopes too.
Yes.
There's mirrors underground and stretchers, movable mirrors, so they can get the optical paths exact, so they can line them up and everything else.
well, did I miss where this is? Was that northern Chile?
Yes.
Yeah.
Okay, got it.
Holy cow.
What is this?
That's the sphere instrument there, that big black piano with the silver tub.
Yeah.
Okay.
So this is attached to one of the big telescopes in the Very Large Array, the Very Large Telescope, the VLT, in here. And what's inside there is a series of imagers and spectrometers.
Are all those pink tubes?
And it's
connected?
it's an acronym nightmare in here.
Yeah.
But this NIR stands for near IR.
Mhm.
This is visible. And I forget, I don't know what that means. Wide field spectrometer.
Hmm.
Anyway, it's the instrument that's used there. They're not so much, they do images too, but they also do a spectrometry. And this instrument has a disk that blocks the core of the star. And what they're looking at is they're looking at preplanetary dust disks around
Jerry,
stars.
can you blow that up, or is that?
So you can see where it says Corono. Those are the disks that they use to block it. So visible corona and near
NIR
infrared corona.
coronal.
The visible's off to the right.
Yeah, vis coronal.
Oh yeah, there it is. Okay.
Yeah. So with that, they get data like this.
Oh man.
And this is the blocked sun, and you can see the glare that they're suppressing. They also use adaptive optics.
Yeah, oh God.
And the disk, and this is a bright ring around that
Star.
It's the dust ring where planets are forming.
Oh man.
Well, how about exoplanets? Did they ever see those?
It could be, there's knots in here. Now, this is another picture showing these rings and gaps in the rings. And here's a Jupiter-sized planet that is apparently causing this gap in the dust. So this one has soaked up this amount of dust to form itself. But there's still a lot of dust out here for other planets to form, and in here.
Now, are they is that planet clearing the ring?
Yes.
Okay, okay.
Now, these are the 51, they put together a very dramatic set of 51 images of the dust around different stars.
God.
And they use the HD number, so there's no common names, but these are going to be too faint to have common names anyway.
Yeah.
But you get some that are like face on, perfectly symmetric rings. You get them that are tilted like this and tilted like this, and some that are edge on like this and this.
Wow.
So this
That
is a
one in the
very
middle
definite
bottom
picture.
is spectacularly edge on.
Yeah, yep.
Yeah.
Here,
Is this a single star that they're?
Yeah.
yes,
Okay.
these are all, yes.
Okay.
No binaries that I spotted the other night or anything, but
It's amazing that they all have that commonality of the ring that's forming the planets.
that's how they all formed. That's how we formed.
Yeah.
Yeah.
We looked like this once.
And that's what they're looking for. So
Yeah.
pretty common.
It's amazing. It's amazing stuff, Jerry.
Okay, now this is a little precursor.
It's really washed out.
Oh, okay, thank you.
Yeah, this I'm going to be interested in this guy. Here you go, Tommy. This is one I don't want to build.
It's Gregorian.
Yeah, just anything with a hole in the middle. I saw Jerry do it, and it looked easy, but I bet it's not.
No, it's easy.
Mm-hmm.
So anyway, this is the difference between Gregorian telescopes, compound telescopes, and Cassegrain.
Mm-hmm.
We're probably more familiar with Cassegrain, and that is that it has a parabolic primary, and it has a hyperbolic secondary, and it's a virtual focus up here, and it forms this focus back here. Now, a Gregorian is a parabolic primary, but an elliptical secondary, which is much easier to make with the focus up here. So this is outside of the focus. Here, the focus is here, and the secondary is placed inside of focus. So this it takes the light from the focal plane, which is expanding, and it refocuses it back here. So the arrow here is up, the arrow here is down. That means that this system flips the image top for bottom. It's upside down. And this one preserves it. That's not the reason that they do this. The reason they do this is that this shape on the secondary is much easier to make and easier to control. And so
on the Cassegrain or Gregorian?
In the Gregorian.
Now in the Cassegrain, they can use a spherical primary, and that's easier.
Mm-hmm.
So you choose your poison.
Wait, which one is the spherical? The
Cassegrain can have a spherical
well,
primary.
The
yeah, but it needs a corrector plate then.
Yeah.
The secondary in a Cassegrain that is spherical is a Dalkirkham.
Okay.
Or if you have a corrector plate, the whole corrector plate can be spherical and you have the Maxuda.
Yes. Then or a Schmidt Cassegrain.
Yeah.
So
God,
there,
Anyway, that's a
always wanted
contrast
to know
between
those differences.
Cassegrain and Gregorian. And this is a telescope called the Sphere. The telescope is here, and the telescope is actually these panels here. It's a scanning system. This is the receiver over here, so they reflect this way and bounce in. And this is a giant shield built around the thing. Now, this is a Gregorian type telescope.
Yeah, and it's not the sphere. We looked at the sphere was that instrument we saw earlier.
Yes, that's correct.
That AC telescope.
Yes, good point.
Okay.
In your list of reflecting telescopes, you left out the Matsutov, which is all spherical surfaces.
Yeah, I wasn't doing a contrast of all the telescopes there are. I was just showing the difference between two principal ones, because this is a Gregorian, and Cassegrain is what we're used to mostly. But there are a lot of variations on it. We can do that one time.
I'd love it.
My 5-inch is a Matsutov.
well, I don't know how this could focus anything. It looks like a Disney.
No, light
distraction.
or the photons come in this way, they bounce off this, and they go here to this receiver.
Oh,
This is
They test it with a marble.
Yeah.
yeah. This is the Atacama Cosmology Telescope, and this is a shield, a baffle around it to keep extraneous light out.
Huh.
so
And
there's
this,
lenses down in there, big lenses we don't see, I guess.
no, you see it right there. There, the lens was right there. There's no lens; it's a mirror. These panel mirrors.
But they're angled. They're not smooth and round and curved.
Yeah, it's tipped. It's tipped to look this way.
Oh, okay. Well,
What you do is you take the mirror that you want in total, and you take a piece out of it that's not on the center, and that's what you're looking at here. It's an offset piece of the mirror.
Now this shows
CMB and polarization.
yes. This shows the Atacama what is it? Atacama
Cosmology.
Yeah, ACT from an oblique view with all the guts inside. And this is a map of the cosmic microwave background. And the little short black lines show the polarization of the light that comes from that. And the importance of this is a breakthrough, because the cosmic microwave background has been imaged before from, by the way, this is a microwave telescope. It's not an optical telescope. This is microwaves. And it has been imaged before from space. And that's what we see is the precision and the temperature changes of the spaceborne spacecraft images. For this, it's done from Earth. And the information is equivalent to or better, sharper focus than the spacecraft. Mm-hmm. So now the future studies are being done from the Andes, and we're not going to put any more spacecraft up to look at the CMB. And
is that because it's bigger than the spacecraft telescope?
Say that again.
Is it better because it's larger than the spacecraft telescope?
Yep.
Yeah, there's a lot of advantages to this. The advantage of the spacecraft is it's above the Earth's atmosphere, but this is
right.
This is very nearly above the Earth's atmosphere, and it's above most of the Earth's humid atmosphere.
But microwaves are just below infrared on the big spectrum?
Yes, they're less energy than they're what's used in your microwave oven.
Really? Okay, I was going to ask that next, but they're part of the radio spectrum then, right? Radio waves. My old radio station is below that somewhere, right?
Yes, it's longer wavelength than that.
Okay, got it.
So this is at 16,400 feet.
And
And
it
this,
doesn't move, it's just aimed up straight?
no, it scans the system. It scans side
Yeah,
to
that
side.
part in the center that's tilted can rotate around and point at different parts of the sky.
Oh, I see, okay.
Yeah.
Boy, man, I pity the guys that built that.
Why?
Oh, 16,000 feet. I mean, God.
Those are the guys that delivered it and installed it, not the guys that built it. So anyway,
But yeah, I pity the guys that installed it.
yeah.
Well, we don't,
Anyway,
Well, probably Indians from
this
the
now is
Andes.
a third source of Hubble constant measurements. And this verifies the spacecraft when they're, remember, there are two ways of measuring the Hubble constant. One is to look at recent stars, and the other one is to look at very old stars. So this one,
or the background.
yeah, excuse me, the background, that's very, yeah, pre-star. So this is another look at the background, and it confirms the spacecraft view of the cosmic microwave background. So it adds weight to the tension being a real thing. So it's physics that we have to somehow add to our, what is it called, the standard model of the universe. Difference in Hubble constant, and it's probably erroneous to call it a constant, but the difference is real. There's a lot of graduate students that are launching their careers in this field right now. Good luck to them.
Mr. President, you've listed in your talking points the Hubble tension. Is any of this part of that?
Yes.
That's what he was just talking about, Ron.
I didn't hear the word tension. I missed it.
Yeah, this is the data for the Hubble tension.
Okay. But the JWST, is that a part of that?
No.
No.
Oh,
Well,
no.
It's all earthbound.
This is
Do the lines that are on there represent come on, polarization?
Yes.
Yeah, the little
Okay.
lines here are polarization. So you've got temperature differences in the color, with dark blue being cooler, and not by much. These are like 10 to the -4 degrees difference between hot and cold. So these are hotter regions in the primary fireball. You're looking at it, this is about 380,000 years after the big initial push. Or as Calvin and Hobbes calls it, the tremendous kablooey. And these are polarization vectors of that. So the little lines indicate a polarization direction.
And magnitude.
Magnitude of polarization. Yes, the color is the magnitude. The line is the
No,
polarization.
the length, right? The length of the lines.
Is polarization.
I know, but the length of the polarization lines is the magnitude of the polarization.
Yes. And so is the color.
But these two squares represent just a small part of the background radiation.
Yeah, this you've seen it before. You've seen it as big elliptical map,
big oval,
the whole sky.
Big oval, yeah. With models.
This does the sky in bands or swaths.
And this is a little patch.
Okay.
Wow. The resolution is really high on this.
Yes.
How would they measure something that small of a change?
Yeah.
That's
very
really
carefully.
This is one of the swath pictures from the ATC, ACT, and it's reproduced very badly here. It has yet to have the Milky Way subtracted from it, but in the background you can see, and these are individual swaths that it takes, so it hasn't built up a whole image yet in this. We have a see here.
That's why there's that black stripe over there on the left. That's where the two images didn't quite line up, I gather.
Lost in
Hang
Zoom
on just a
space.
second here. Judah.
Please stand by. You have time to go to the concession stand and grab some popcorn.
Yeah. Okay, hang on. Now let's see if we can do this. Where is the dang? There it is.
Ooh, a movie.
This is a movie taken from the spacecraft. Was Comet 3I. This is Comet Swan. You can see the tail going out this way.
And you can see some real hula hoop stars there.
Yeah. There's Comet 3I Atlas it passed.
Those must be orbiting spacecraft that you're seeing there, because they're moving relative to the background.
Yes, I think they are. You know, when you look out in space and you see synchronous satellites that orbit and they stay roughly over one spot of the Earth, it's only roughly, it's not perfectly aligned. If you look at those in your telescope, you will see them drift over several hours. They do move because the Earth is not perfectly spherical.
And if you're tracking something like the comet, then they really appear to move.
Yes. Yeah. Anyway, I was hoping this would show the
It's a graphic illustration of the tail direction.
yeah.
Why did you say hula hoop stars, Chuck?
Well, did you see those blobby things that were wobbling like that?
You mean they look like little rings? That's what a hula hoop would.
No,
designate.
but it looked like it was
Still
wobbling.
swirling.
It looked like it might be a satellite with two solar panels that was rotating.
Oh yeah.
If you guys lock onto a comet any night, do you actually see it move during the time you're watching?
Sure, yeah.
You can, huh?
Depending on how far out it is.
Yeah. You won't see 3I Atlas move out. I didn't include any of the 3I Atlas in this week's thing because they're really not adding anything. They're just still fuzzy balls. But I noticed that the hype about it being a mothership and we're about to be invaded and stuff is really reaching a peak. I'm tempted to do just a bogus science hour.
Yeah.
That would be great. That'd be great.
Well, can you answer one question about it, Mr. President? It comes in from outer space, it
Yep.
enters our solar system at one angle, and when it gets close enough to the sun, it changes its vector or
Yep.
its trajectory. What part of that is it on? On the inward or the outward, or is it?
It's on the outward now.
It's on the outward. It's
I
already
think it just passed the inward.
okay.
So if memory serves me right,
Yeah.
if you have something in the sky that is moving, 3 observation of it, provided they're precise enough, is sufficient to determine the path that it's on. And the path it's on will be a conic section because it's central gravitational field. So it will either be hyperbolic, elliptical, parabolic, or circular.
And the complication with comets is they spew stuff out, which acts like a little rocket. And so they change a little bit each time you look at them if they're active enough. And that's what they call non-gravitational acceleration. And that's what all these crazy folks are hyping on, saying, oh, it's changing its course.
Yes, and it is, but it's not intelligently driven. But that's the difficulty, like with Apophis, the asteroid that is going around, and is it going to do a near pass of Earth in 2029? I think it is. That it may have some volatiles on it, and it may adjust its course slightly. You can certainly mathematically determine what the present orbit is going to look like forever, but it may change that orbit with a sudden burst of outgassing. You never know. And that's where the uncertainty comes from.
Yeah.
Can I add yet another stupid, silly question to that, what you were just saying? How in the world does water get created? It can't be made in the middle of those explosions and give us everything else, can it?
Yeah.
We put fires out with water.
Well, Ron,
I
stars
understand.
aren't doing fire. Stars are doing thermonuclear reactions.
Okay.
So they make
They will-
oxygen. Once they've made oxygen and spew it out, it's going to combine with hydrogen.
Right.
Okay, but during the nova?
Yeah, when it's rushing out and things are calming down, nuclei start picking up electrons and they can form the different kind of bonds that'll make hydrogen and oxygen. Hydrogen sees an oxygen and an oxygen sees a hydrogen. It goes, oh boy, and they join, and that's it. That's where they come from.
Ron, think of the Hindenburg explosion. You've seen video of that, right?
Oh yeah.
Okay, so what the result of that was a huge cloud of steam.
Yeah, I understand that. Yeah, when you burn hydrogen in a car, you create water. It's just hard for me to imagine them living together. It has to have been created later in the rings around the new solar systems or something.
There's a lot of energy out there, and they could get hit with something that breaks them apart. But in large part, the universe is full of water. It's an easy and common molecule to make.
Another thing, Ron, I don't know how this fits you guys, but I think at one time, people suggesting that the water on Earth was made by the comets, that the comets delivered the water.
I did hear that. But can water exist in the fourth type of matter? It can be solid, it can be ice, it can be water, liquid, it can be gas. Does it also plasmate or become plasma?
Then it wouldn't be water.
Yeah.
Well, in other words,
it needs the electrons to bond together.
Plasma would take the hydrogen and oxygen atoms apart.
It would take all the electrons off the nuclei. The nuclei will not form water.
So does plasma do that to every conceivable compound
it's
or element?
ionized stuff? Yes.
Yeah.
Not just water. I like water. I'm glad it's out there.
Yeah.
I'm glad it landed here on Earth, Jim.
Well, and you can tell somewhat what the source of the water is by looking at the isotope ratios of the oxygen and hydrogen.
Right.
And a lot of it seems to have come from meteorites bound inside the mineral structure. Because it doesn't match what we've seen. Sometimes it does, and sometimes it doesn't match what we see in comets. So there's a whole bunch of different sources of water.
That's interesting.
But that's the main thing that gives the comet its tail. Also, CO2 can make a tail.
Yeah, there's carbon monoxide, carbon dioxide, all kinds of ices.
Does carbon dioxide and monoxide have a liquid form like water does, like steam? Can be the three. I can't imagine a liquid carbon.
It depends on the temperature and pressure you're dealing with, but yeah, you can do that.
I wonder where you see it.
Every element has a phase diagram where pressure and temperature determine what state it's going to be in, whether it's going to be in a solid, liquid, or gas or plasma. Except for the ICE 9, I've never seen that on a phase diagram.
Only in Vonnegut's books.
Oh.
Yeah.
But the metals that are inside comets, your metallic elements, they never steam out and turn into tails, right?
Yeah, no, they detected a lot of nickel in the I3I.
There are planets and stars where it rains iron.
Oh, for crying out loud!
I think I'm with Ron on some of that because if it's comets and meteors that deliver the water, it's hard to imagine them coming in at that velocity and that water, making it through. But then Chuck said it's inside the structure of the hard stuff, and that's how I get it.
When they come into our atmosphere and burn up, that stuff doesn't just disappear.
Yeah.
You know, it becomes part of our atmosphere and eventually comes down.
Yeah, there you go. So that's part of it.
Well, water is being manufactured all over the universe pretty much the same way it was manufactured before here.
That's the theory.
And I'm amazed at just recently understanding that. I just didn't think that water was so prevalent, but apparently it is.
Yeah.
Well, if you look at the diagram that shows how much of each element there is out there, the elements on up before iron, so especially carbon and oxygen and stuff like that, the stuff that makes life is actually among the most common stuff out there
Yeah, hydrogen.
because it's made in lower mass stars, and most stars are lower mass.
Yeah, yeah.
But if comets and asteroids gave us the water we have on Earth, then it did the same thing to Mercury and to Venus and to Mars. They just all lost their water.
Yeah.
Unless it's still buried in Mars, of course.
I think that the thinking now is that it is.
It's chemically bound with iron. That's why it's red.
You suppose it's on Venus as a real high layer of
Yes, absolutely.
fog?
Oh, there was something on that. I just read that.
Wow.
Yeah. And speaking of Venus, you can still see it in the morning sky. I saw it this morning.
Oh, wow.
Yeah, I
It's
also
getting
saw
close.
Mercury on Saturday morning, way high up.
You guys are so awesome.
About 7 o'clock.
Is Venus a crescent?
I
No.
just use binoculars. I don't think it is. I think it's looking more like a ball, right,
Yeah, I
Chuck?
think it's close to a gibbous, or it's
Yeah.
close to full.
Yeah,
No,
okay.
it's on the far side of the sun.
It's on the other side then.
Yeah.
Okay.
Figured that out.
So the last topic for today
Ooh,
is
there we
the
go.
James Webb Space Telescope has taken a dramatic picture of bridges between dwarf galaxies.
Oh, nice.
Dwarf galaxies are of interest because galaxies are believed to have started all as dwarf galaxies. So when we look at dwarf galaxies nowadays close to us, it's the structures that were there in the beginning of the universe. And this is a region around NGC 4490. This is the region of galaxies. This is the Big Dipper, the Ursa Major. There's Polaris, the pole star.
Mhm.
And we go right down here near Chara, and there's the region we're looking at. And this is a picture of the
Yeah.
bridge between dwarf galaxies, distant galaxies. And this is a cluster of things, NGC 4490 and 4485. And this is the bridge between them.
Is the red the bridge?
Yes, the red is the bridge.
I think Chrissy showed us this last Tuesday. We're taking her her little astro course on
Yes.
Tuesdays, and she
Yeah.
showed this image on the dome. That's pretty neat.
Mhm. Yeah, this is a very recent image from JWST, just released this week, earlier the week.
All that red gas is a bridge between two dwarf galaxies?
Yes.
Where are they? Where are the galaxies?
That's the bright stuff.
Yeah.
There's
There you go.
one.
But they're not
Oh,
part of our galaxies?
This is one up here.
Yeah.
Right.
And the other one is area over here.
That's
These
it.
aren't the Magellanic
Yeah, the other
Cloud.
one's an elliptical, the one you pointed to originally.
Yeah, it's
Yeah.
way in the background.
Mhm.
And then this one up here is an elliptical also.
Okay.
Mm.
Wow.
So this is a bridge of gas stretched between these things.
Yeah, Jerry, look at the structure on that galaxy in the lower right. Yeah, you got your cursor on it.
Yeah.
Wow. That's some detail, huh?
No, is it that bridge? Is that like an accretion?
And
No, it's kind of been pulled out. It's a tidal tail type effect.
It's a sharing, Tim.
It's sharing, huh?
Yeah.
But do dwarf galaxies also come in spirals and barred middles and elliptical.
Well, the
That's a
Large
good
Magellanic
question. I don't
Cloud
know.
has a bar structure.
Yeah.
It does. Okay. But
So
that's what makes the big galaxies. All these little ones collide together over.
There is kind of a density in here, sort of a linear density there.
So in this sharing, is this why there's going to be maybe a commonality of elements in each galaxy?
This is primarily hydrogen.
Okay. Okay.
The red.
Yeah. Yep. Again.
God almighty.
So did I miss the
These
part about
are these blue regions are star forming regions in the cloud of gas and dust, the red clouds.
okay, but what they're sharing them, or there's one sucking from the other? How does that work?
Either one of those will do.
It's kind of been splashed out by the interaction between the two of them.
Huh.
I mean, they're big nebula for all intents and purposes, aren't they?
Yes,
Nebula
it is.
just means cloud, yes.
And we're finding a lot of galaxies that are in chains of material like this. One where something like 7 or 8 spiral galaxies are all hooked together by one of these bridges.
You see that in Stefan's quintet.
Well, yes. You see it in. Okay.
But pretty much everything in the universe is spinning in some way, isn't it? Even the dwarf galaxies, everything's turning. Nothing just sits there alone.
That is a very big question for astronomy right now. Is everything turning? Are all of the galaxies rotating the same way?
Oh boy.
There's a rotation to the universe, or are they all randomly rotating? And now their different groups are claiming different aspects of that. So,
well, there was just a big, along one of the cosmic strings, there was a huge group of galaxies that are rotating along in this tube-like structure. And they're all rotating together. So it's like a siphon, like a little whirlpool in your bathtub.
Yeah, cosmic tornado.
Yeah.
So they all have a flat elliptic of their own. They're all saucers. There's no stellar systems that look like atoms ever. There's no way that planets go.
No, I wouldn't say that. I mean, if you look at Jupiter and its moons, it looks like a total, beehive structure.
Well, that's a planet thing, though. But
yeah, well, that's the same. The same thing can happen when you have a central large gravitational object and things that gets captured by it. So,
but it just seems to me if something starts spinning in this primordial dust, it's got to go flat.
No, well, that's true, but you're jumping ahead. When you get a big cloud of everything together, gravitationally attracted, they're just have a certain temperature. They're all moving in random motion with respect to everybody else. And as they collide with each other, that's a form of friction, and they exchange energy and they exchange and average out the angular momentum. And so the big glob of thing gradually picks up a single rotation if it's big enough.
Wow.
Our planetary system, our solar system, started as a big ball like that. Most of the inside of it collapsed into a disk because it had defined a single angular momentum. But part of it out there, the Oort cloud, has not done that yet. It's still got its original spherical shape.
Man, the math of that has to be just nuts.
You're right about that.
So,
and other than
there's a white streak.
Go ahead.
There's a white streak in the middle of that picture off of one star. Is that a jet?
That's Comet Swan again.
This one.
Oh, okay.
And then those two bright blobs on the left are the satellites that were doing the wiggle.
Right.
Okay.
And
the hula hoops?
Yeah.
Yeah, this is a single frame from that video I showed earlier of Comet Swan moving this way.
Oh, yeah.
Moving in the direction of its tail?
Yeah. The tail is away from the sun, and Comet Swan has to be moving this way.
Yeah.
I can remember my science teacher in the 6th grade saying, yeah, all the tails around comets point away from the sun for some reason, but science doesn't know. And I was
giant tail points away from the sun. The dust tail doesn't necessarily. It tries to.
Well, I could figure it out in the 6th grade. Well, that's, the solar wind doing that.
Well,
Gentlemen,
that does that to the ion tail.
did we run out of steam or
Uh-oh.
We
CO2?
ran out of minutes.
Did we manage to give away the 2 kittens from?
We're gonna be reionized here, and we'll condense back down a week from today.
Okay, well, look, that does it for December 8th to 14th. That's number 251. In 3 months, we restart our 6th year, everybody. We'll be back next week to find out if Tim's giving away the kittens. We're going to meet for breaking bread on Thursday night out at the Hilton. That's our big party. I'm going to wear my Santa hat. And we'll be back here next Monday morning for the Astro Hour. Once again, gentlemen, how in the world do we say goodbye in astronomical talk? Is there a way to do that?
Nebula.
Hey,
There you go, Chuck. There you
Thanks,
go.
everybody.
Bye, Mrs. Calabash, wherever you are.
You're right.